All right, solving logs. So to get rid of a log, you have to do an inverse base. So in this instance, this is log, so that's base 10. Now, I'm not dividing, I'm not multiplying, I'm saying 10 to the log power. So this is a base, this now becomes an exponent. Well, they're inverses of each other, so they cancel out. And now you can solve that. So subtract 10 on both sides, divide, or I can add the 4x, so x equals 0. Now, you have to check for extraneous solutions, so you have to plug this back in. And so you're going to get log of 10 minus 4 times 0, which is 0, so 10 log 10. 10 minus 3 times 0, so that's 10 minus 0. So those equal each other, so then I can say that that's a solution. Now, for you to be able to perform any of these operations, the log has to be isolated. So this log part has to be by itself. So I need to raise that 2 as an exponent, or you can divide both sides by 2. Both of them work. So the laws of us solving an equation all are the same. Then I can turn this into an exponent, so base 7 to both sides. So 7 to the 0 power is 1. R equals negative 1/2. And so again, we have to go through, plug it in. Negative 2 times negative 1/2, that's 1. Log base 7 of 1. So what power do I need to raise 7 to get 1? That's 0. 0 times 2 is 0, so it works. For number 3, I have to condense the log. So I have to combine these logs. So there's 2 factors. So 2 factors. And then I can do my inverse base. This is 10 to the first power. Divide both sides by 2, and you get 5. For ln, again, 1, 2. That's on top. The 3x plus 2 is on the bottom. I can take e to both sides. I can multiply both sides by it. Now remember, I'm solving for x, so divide by e. Add the 2, or sorry, subtract the 2. And then divide everything by 3. Now this one is weird, because to get rid of ln, that's log base e. So I do e to both sides. That cancels out, and I get x squared minus 99 equals e to the 0 power is 1. Anything to the 0 power is 1. Add 99. And so you get x equals plus or minus 10. Now you have to check it. You do have to plug it back in. All of these you have to plug back in, and you have to check. And so does both of these work? So positive 10, yes. Negative 10, yes. So both of them work. Condensing these, I can raise this as an exponent. And so these are positive. Sorry. These are positive, so that's on top. This is negative, so that's on the bottom. So I'm going to get log base 2. It turns into 1 log. Positive, positive, so those are on top. And then my negative, so that's on the bottom. You can still cancel out. And so you go log base 2 of y. But also, positive log base 2 and negative log base 2, those would have canceled out there. And then you can't forget the exponent. Raise up to 6. Log base 4 of v to the 6 over u. In terms of expanding, these are 3. So you're going to get log base x plus log base y. Or sorry, log of x plus log of y plus log of z squared And then this, since it's log base 2, I have to unsimplify it. And then minus log base 2 of 2 to the 4th. And so this will become log base 2 of x to the 4th over 2 to the 4th. It says find the missing side of the right triangle, leave your answers in radical form. And so this is, 45, 45, 90 triangles. So that's t, this is t, this is t root 2. So if t is 9, I can plug it in for t. So y is 9 and x is 9 root 2. So solving these, remember, if you can't make the bases the same, you take log to both sides. So you get log 2 to the x equals log 9. I can move the x to the front. Divide both sides by log 2. And so there's my answer. Finding the inverse, you switch the x and y. And then to get rid of the log, you convert it into an exponential equation. So that becomes 10 to the x equals 4 minus y. Subtract the 4. And then multiply by a negative. To get rid of or solve a rational equation, you just multiply by what's in the denominator. So I have an x in the denominator, so I'm going to multiply everything by x. And those x's cancel out. Then I have a 5 in the denominator, and so you're going to multiply everything by 5. And then I have a 2 in the denominator, so I'm going to multiply everything by 2. Subtract the 10. Divide by the negative 8. Now in evaluating, what power do I need to raise 3 to get 27? I can rewrite that as 3 to the 3rd power. So those are going to cancel out. I'm going to be left with 3. Remember, we can rewrite these as fractional exponents. And so those are going to cancel out, and so you're left with 1/2. And same thing here.